pad that you can use. In this particular case, we use the Polar Finder program, and just to kind of confirm that we have it in the right spot, and there we have it at this particular time and location. Polaris should be at 10 o'clock on the circle, and that's where we've placed it when we look through the polar scope. Now that it's dark enough, we've added our lens shade to keep the dew off the front cover on the telescope, and we're wanting to just make sure that the red dot finder is pointing exactly where the telescope is. So I see Arcturus over here in the west, almost directly to the west. So I'm just using the controls on the hand controller to move the scope until the red dot is pretty much right there on Arcturus. And then what we'll do is we'll take a look on the camera to make sure that it's pointing in the same place. And we have Arcturus right there at the top of the screen, so we're going to want to just bring that down into the center of the frame. And that's pretty close there, at least for our purposes. And we'll make a very slight adjustment on the red dot finder so that it is pointing directly at Arcturus. So that's going to just help us with our star alignment for the go-to functions on the telescope, so that the hand controller and telescope can actually find the objects that we're wanting to shoot. We're ready now to do our star alignment with the scope, so the go-to functions will work and be able to find the targets that we want to image tonight. I just want to emphasize that even though this is often called a 1 or 2 star alignment, the alignment has absolutely nothing to do with polar alignment. That's a very different function. What we're doing now is simply enabling the go-to functions of the telescope to work for us. So we've entered the date, time, and location as we showed you earlier during the daytime. And now on our alignment, we've chosen the 2 star alignment, and the first star that comes up is Arcturus, and that's what we were using to line up our red dot finder. So we'll just hit the enter button, and it knows if it's pointing at Polaris that it should be going over in this direction to get lined up with Arcturus. And this is where having that red dot finder nicely set up, we can put the red dot finder directly onto Arcturus and follow the instructions. Has to go down. Red dot finder there now on Arcturus, and we'll hit the enter key as it suggests that we do, and you can see that it's very, very close. Now it slows the motors down on our alignment, and we're just going to bring that into the center of the circle, and as the scope says, then we press the align key. Before we move on to choose a second star, I'll just note at this point that we're not doing the fine focus, but we're going to be doing some focus here, and we can enlarge that star 5 times and begin to adjust our focus knob to just bring that star in as close as we possibly can, even go up 10 times. It's too bright of a star to do real fine focus on, but we're getting ourselves very, very close to it. Ready to do the second star, and I'll scroll through until I find a star that I like. It's suggesting Alcor, which is nice because it's close by, double star near Mizar, and hit the enter key. We're going to probably try imaging the Whirlpool Galaxy, and so that's going to be between these 2 alignment stars, and in many ways that's probably the only stars that we'll have to choose for our alignment tonight. So once again, looking through the red dot finder, it's much closer than it was the last time, and I want to line up the red dot finder with Alcor, middle star in the handle of the Big Dipper, and there we can see on the screen now that we've got the 2 stars, Alcor and Mizar. We know that Mizar is the double star. That's Mizar. As you can see, there's a double star there. We're just going to adjust our focus to try to get those stars nicely in focus, and then we'll go back and choose Alcor as our alignment star, which is the one that's on the screen just to the top. So we just bring that down into position and hit the enter key, and then also the line key. So now we have our 2 stars selected for tracking. It's asking if we want to enter calibration stars, and we'll just pass on that. So Now the scope should be tracking the Alcor in the Big Dipper, and we can set up some of the other functions to begin getting ready for imaging. We're now going to do a fine focus using Messier, because it's the double star. We had done our alignment on Alcor, so we're just going to bring Messier up there into the center of the screen. And because of the double star, we should be able to get a really tight focus on there. So I've brought it up into the middle of the screen, and then on the SLR I'm just going to zoom in 5 times, just make sure it's centered, and then zoom in again. And so there you can see the double star. One is of course brighter than the other, and that should allow us to get pretty tight focus separation between those stars. So you can kind of see, just adjusting the mirror, going back and forth out of focus, just bringing it up, bringing it up, bringing it up until it's nice and tight. Gone a little too far, and there we have it. That's going to be a very, very good focus for us, because we won't be able to see the Whirlpool Galaxy on the screen. We want to do our focus at this point, move over to the Whirlpool Galaxy, and know that the telescope is in focus. One of the really great things about the Edge HD is that there are some mirror locks here, and so we're just going to tighten those down so that the mirror stays nicely locked into focus, watching our stars there to make sure nothing is changing as we're tightening those up. What we're doing now is hooking up our AutoGuider. There's the cable that goes from the AutoGuider here. Looks like a telephone cable, clips in, and it goes to the AutoGuider port on the mount. The second one that we'll plug in is the USB cable that goes from the AutoGuider to the USB port on our computer. And tonight we've got our Mac computer. I've installed the drivers for PhD guiding on the computer. PhD guiding and the drivers will work also on a Windows machine. So you have your choice of Windows or Mac for this. And on the screen on our computer, we've opened up the PhD guiding. We have to choose the camera. In this case, it's the Orion Starshoot AutoGuider, and we hit the OK key. So now there's a light that has come on the back of the Starshoot AutoGuider, and it should have connected. I'm going to hit the button to begin looping and taking pictures, and the light will flash because it's starting to take pictures now. So good communication between the telescope and the AutoGuider. And you can see on the screen that we have here, just going to adjust the focus here. It looks like we're in actually very, very good focus. That's simply by adjusting the front objective lens, or on the back of it you can slide the AutoGuider in and out until it comes into focus. So there we have a star that we could guide on. And while we're doing this, we've stopped the capture process. Basically, that was in order to get our AutoGuider focused. What we want to do is go over and take a shot at the Whirlpool Galaxy, Messier 51. We're going to go into our deep sky objects and find the Messier List and choose that. And we want to choose 051 for the Whirlpool Galaxy. Hit the Enter key, and again, it's not going to have to travel very far to be able to be on the Whirlpool Galaxy. Now there's some adjustments on the camera that we're going to do. In the Canon camera, we want to turn off the long noise reduction at this stage so that we can take a picture and we don't have to wait another 30 seconds for it to take a dark frame. So on the Canon camera, you'll find this noise reduction feature under the image, function 2, and so we select that. Each camera is going to be a little bit different, but we want to turn the long exposure noise reduction to off. So we do set it on there, and it says off, and we hit the set button, and we're good to go with that. So it's pointing now at the Whirlpool Galaxy, and what we want to do is take a test exposure. We've put on our intervalometer here so that